Hi guys, tonight we're going to take a look at exponential functions. We've been talking in the past few days in class about how do you write an explicit rule, a y equals rule, when you have a common ratio, or when your now next is to multiply to get from one term to the next. We know how to do it with an arithmetic sequence when it's linear, but tonight we're going to take a look at how do we write it when it's nonlinear, it's exponential, it's geometric. How do I write an equation for something like that? So let's go ahead and get started. Okay, so your spaceship has crashed in an unknown planet. You and your crew encounter a drooling, carnivorous alien monster. While you are cowering in the cave, your science officer is able to chart the monster's growth over several hours' time because he has nothing else to do. She notes that with each hour that passes, the monster doubles in size. Specifically, we're talking about the monster's height doubles in size. So if we assume that the monster is 1 foot tall at birth, what formula would describe the growth rate of the monster? So we're assuming time in hours, the monster started out at 1 foot in height. If it's doubling every hour, that means 1 times 2 is 2. If it doubles again, it becomes 4. If it doubles again, 8. At the end of hour 4, 16 inches or feet, and then 32 feet, and then 64 feet. So that is a pretty tall monster. So our common ratio is 2. So we're going to write a now next. We did this in class on Monday. We did this in class yesterday. To write a now next for this monster. So our monster started at 1 foot, and our next equals now times 2. So we know it's not arithmetic because it doesn't have a constant rate of change. So it's geometric, which means we're multiplying by 2. So we want to write an equation that relates the time and the height. So when we look at now next, we're looking from how do we get from here, from 1. When we look at it now next, we're looking at the output. How do we get from 1 to 2, 2 to 4, 4 to 8, 8 to 16? And by that, we're multiplying by 2. And that's how we get our now next over here. So if we want to write an equation that relates the monster's height, if we want to know how tall the monster is, let's look at all of these values in the output. When the input was 1, the output was 2. How can I get from 1 to 2? Well, I can do times 2, and that works for this one, but it doesn't work for 3 times 2 is 8. So let's look at our growth rate, or our common ratio, which is 2. We're also going to call this is also the growth rate of this particular alien. The growth rate is 2, so we can write this equation as the height of the monster. It starts out at 1 foot. It's growing 2 feet, or doubling every hour. And we can have the exponent on the 2 be the time in hours. So h is the height of the monster. T is the time. The 1 is the start. How tall did it start out at? And the 2 is the common ratio, or the growth rate. So will that work for every geometric equation? It sure will. And we're going to look at a general formula for that in a minute. So based on our equation, how tall will one of these monsters be 6 hours and 30 minutes after it's born? So we're looking at a time of 6 hours and 30 minutes, so that's 6.5 hours. So we want to know the height of the monster. It started out at 1 foot. It's doubling, and our time is 6.5 hours. And when we multiply that out, we get a monster that is 90.5 feet tall. How tall would the monster be after 4.7 hours after birth? So again, We're looking at our time as being 4.7. We're going to use the same equation. The monster started out at 1 foot. It's doubling, and we need the height after 4.7 hours. So that would equal 26 feet. So just to backtrack for a second, how do I know that the 2 is going to be my base? Well, if we look at 2 to the 0, 2 to the 0 equals 1. 2 to the first equals 2. 2 squared equals 4. 2 to the third equals 8, and so forth and so on. It works the same way. So back to question E. Go ahead and do question E. How tall will the monster be after 3.2 hours? So our time is 3.2 hours. The height of the monster, it started out at 1 foot. It's doubling, and we want to know how many times it's going to double its height in 3.2 hours. And again, if we multiply that out, we get the height of the monster is 9.2 feet. So this equation that we wrote over here, this equation right here, that's what we call an exponential equation. It's exponential. We can also call it explicit because it's a y equals. Let me make this a little bigger so you can see it. The 2 is the base of the function. It's the growth rate. It's the common ratio. And the t in this case is the time. In our example, it's the time in hours. That's the same as our, that's our exponent. And that's our x value. It's our input. So we're going to look at this general formula. And the general formula we're going to look at for an exponential function is y equals a times b to the x. And that's what we just did. So our a is our start. That's where we're starting out in our now next. And our b is called the growth factor. In this case, it's a growth factor because it's bigger than 1. That's also our common ratio. It's the same thing. So if we look at our now next for our monsters and amoeba over there, or our monsters, our start was 1. Our next was equal now times 2. So this is our b, which is our growth factor. So if we put this in the equation where y is the height of the monster, it started out at 1 foot. Its growth factor, the b, is 2, and x in this case would be time in hours. So this one and this one and the letter a are the same. The b, or the growth rate, is what we did for our now next. It's our common ratio, and that goes right there. And then our x in this particular example is just time in hours. So this equation for an exponential function, y equals a times b to the x, you have to know this. That's the general formula for an exponential function. So let's take a look at part 2. Your team continues to investigate. After encountering a second species of drooling alien monsters, you conclude that the second species is 4 inches tall at birth and triples every hour. So if it's 4 inches tall, that's our start, which is our A, which is 4 inches, and it triples in size. So our common ratio, or our B, it's tripling, and that means times 3. So if the alien is starting out at 4 inches, but we want to write that in feet. So instead of writing 4 inches, it's 4 out of 12 inches, which is 1/3 of a foot. So if it is tripling every hour, if we multiply 1/3 times 3, we get 1. If we multiply 1 times 3, we get 3. 3 times 3 is 9. 9 times 3 is 27. Then 81. And then 243. So this first one is where we wanted to be careful. It started out as 4 inches, but we had to write that in terms of feet, so it was 1/3 of a foot. And then we can go ahead and write the rest of our numbers in our output. So for our now next equation, this monster is starting out at 1/3 foot, and our next term in the sequence is to take our now times 3. So again, this is our start in our equation. That would be our letter A. This is our growth factor in our exponential equation. That would be our B. So question C, write an equation that relates the time and the height. So if we want to know the height of the monster, it started out as 1/3 foot. It's tripling every hour, and we're going to let t equal time. If we wanted to write that as a y equals, same thing, 1/3 times 3 to the x. We could write it like that as well. So if we look at our exponential equation from before, where we have y equals a times b to the x, this is our a, this is our b, our growth rate, and x and t are the same thing. So letter D, how tall will this monster be after 2.5 hours? So if our time is 2.5, we want to know the height of the monster. It started out at 1/3 feet. It's tripling every hour, and we want to know what it is for 2.5 hours. And if we multiply that out, this monster after 2.5 hours will be 5.2 feet tall. Part F, how tall will the monster be after 4.2 hours? So our time is 4.2. Our height is h equals, it's starting out at 1/3, it's tripling every hour, and we have 4.2 hours. And if we multiply that out, the monster after 4.2 hours will be 33.6 feet tall. Okay, the last one I want you to try by yourself. The alien monster, you find a third species of alien monster. You find that this species is 2 centimeters tall at birth and gets 5 times as tall with each day that passes. You need to write a now next equation, create a formula to describe the monster's growth, and how tall will the monster be after 3.7 days. So for each of these you need a start, and you need to know what the growth rate is. So where is the monster starting out? The monster is starting out at 2 centimeters tall, so our A is 2, and it's getting 5 times as tall with each passing day, so our growth rate, or our common ratio, is 5. So our start is 2, and if we write a now next, next equals now times 5. So create a formula to describe the monster's growth rate. Well, the general formula for an exponential expression or equation, explicit, is y equals a times b to the x. This is our a, that's our start, and we're ready to find the b up here. So our equation will be y equals, it's starting at 2 centimeters, it's getting 5 times as tall with every day, and x equals the number of days that pass. So to figure out how tall the monster will be in 3.7 days, It's just y equals, it started at 2 centimeters tall, it's getting 5 times as large every day, and we have 3.7 days. So if we multiply that whole thing out, we get 771.3 centimeters tall. Okay, real quick, just to recap, so we know what we're talking about. For an exponential function, an exponential function means that's the same as a geometric sequence. It's where we multiply to get from one term to the next. The general formula for an exponential function is y equals a times b to the x. A is our start. B is our growth rate. In this case, it is a growth rate. It's also our common ratio. And then x is our time. And it could be in days, it could be in years, it could be in hours, it could be in minutes. So if we look at this in comparison to a now next, if we were to write our now next, our start is the same as a, and our next equals now times whatever our growth rate was. So in these two questions, for multiple choice question number 1, using the exponential growth formula, which again is y equals a times b to the x, what is the growth factor for the example below? So this is actually not a growth factor. This sequence is getting smaller, so we're going to call it a decay factor. How are we getting from 10 to 50, 50 to 25, 25 to 12.5, and 12.5 to 6.25? So this one I'm just looking for the b. That's all we're looking for in this one. Question number 2, write an exponential growth equation for the example below. Okay, first you need to find how are we getting from one term to the next. So how can we write a general formula for that? What does a equal and what does b equal? And keep in mind that a is the start and b is the common ratio. Be sure to put your answers in the Google form, and if you have any questions, put those in the Google form as well.